Hi, welcome to Nomis Academy. In this video, we'll be talking about sum to infinity. Sum to infinity. Sum to infinity. Sum to infinity. So now, what are we going to learn about sum to infinity? It's about geometric progression. For arithmetic progression, sum to infinity does not exist because we will not have the terms of arithmetic progression to be infinity, but we will have the sum of GP to be infinity. So we can calculate the sum of geometric progression in infinity, but there is still limitation. The limitation is that the common ratio of the geometric progression must be less than 1. Otherwise, the sum to infinity does not exist too. So let's take that. Sum to infinity. The formula to calculate sum to infinity of GP says sum to infinity. This is the sign of infinity, is equal to A all over 1 minus R. So this is the formula to calculate sum to infinity of geometric progression. For arithmetic progression, it does not exist, but it exists for geometric progression only if R, the common ratio, is less than 1. Is less than 1. So only when R is less than 1. Whenever R is greater than 1, the sum to infinity does not exist. So when you have a question of solving the sum of geometric progression to infinity, you must first of all determine the R to tell whether it exists or not. So for any sum to infinity of geometric progression, you will need to calculate the common ratio to have an idea if the sum to infinity exists before you can proceed using the formula s to infinity equals to 1 all over equals to a. Sum to infinity equals to a all over 1 minus r. Good. Now let's get into an example. Example number 1. Find the sum to infinity of the following GP. Following GP. 2, 6, 18. So it continues like that, and then B, 1 over 2, 1 over 4, 1 over 8, and it continues like that. So let's get into the solution. For the first one now, we need to calculate the common ratio. So for the first question A, remember that R, the common ratio, is equals to second term divided by first term, which must be equal to the third term divided by the second term. So the second term is 6 divided by 2, which must be equals to 18 divided by 6. 6 divided by 2 is 3. 18 divided by 6 is 3. Now the R is greater than 1 because our R is 3. 3 is greater than 1. Hence, we can tell that the sum to infinity does not exist. Does not exist. Does not exist. So let's take the second example. B, which says 1 over 2, 1 over 4, 1 over 8. So let's calculate the sum to infinity. So first of all, we want to tell if it exists or not. So we'll start by the common ratio. The common ratio is second term divided by first term, which must be equal to third term divided by the second term. So for we have the second term to be 1 over 4 divided by 1 over 2, which must be equal to 1 over 8 divided by 1 over 4. So this is 1 over 4 multiplied by 2 over 1, and this is 1 over 8 multiplied by 4 over 1. And since 2 over 4 is equals to 4 over 8, because 1 over 2 is equals to 1 over 2, then we can tell that our ratio is equals to 1 over 2, which is what now? Less than 1. Then the sum to infinity exists. Now let us calculate the sum to infinity. Don't forget, the sum to infinity of GP, sum to infinity of GP is given by S sum to infinity equals to A all over 1 minus R. So remember that A is the first term, 1 minus R, and R is the common ratio. So the sum to infinity of that is the A, which is the first term, is 1 all over 2. Now everything over 1 minus the common ratio is still 1 all over 2, right? So this is equals to 1 over 2 all over 1 minus 1 all over 2. That is, subtract half from a whole 1. So it will be half, definitely. 1 all over 2. So the sum to infinity. So the sum to infinity is equals to 1 over 2 divided by 1 over 2. So that becomes 1 over 2 multiplied by 2 over 1. So that is 1 times 2 is 2. 2 times 1 is 2. 2 divided by 2 is 1. So the sum to infinity is equal to 1. I hope you understood everything we did in this video. If you need to watch again, take your time, watch carefully, and get the formula installed in your memory. Bye bye. See you in the next video.